All right. Good morning, everybody. Good morning, good morning, good morning. This is Honors Chemistry, Monday morning, and we are finishing up the gases chapter. So I just want to just say hi to me in the chat. Let's see who all is here and all that kind of stuff. And trying to get everything open up here. Let's see. We have a test coming up this week. And let me see, how many people on? We only have 4 people on right now. We just we just went down to 2. What's going on? People are like logging off for some reason. I don't know. Now back up to 4. Anyway, so I kind of have a question before we get started on going over this stuff. So I wanted to go over this and then we can talk about the lab if you guys want. So we already went through, let me see, 1 through 3, and then we'll talk about the rest of this assignment because we never did that. And then I posted a review assignment for you guys. It's up on Google Classroom. You guys can find that. It's modified. So if you find the one on OneDrive, the one on Google Classroom is shorter, and so you're supposed to do the one on Google Classroom, the one that I have assigned there. All right. And we have a test. It's scheduled for Wednesday, but if you guys want, I can delay it. Let me see. Do we have to turn it in? The review? No, I decided that I didn't feel like grading this one, so you don't have to turn in your review. It is worth your while, but if you think you know all the stuff, you don't even have to do it. Okay, so the review is not going to be for a grade. It's just going to be just a review, and that's it. All right, and so I'm getting some questions here. And before I answer questions, I just want to see, all right, we got 7 people up, so that's enough right now. I would like to know if you guys are fine for time and would just like to get this test over with. We can do the test on Wednesday, which is what I planned. Or if you guys want to just, have an extra day to just get things done, I can do the test on Friday. All right. I know you guys, sometimes you come to class and you have this contingency of people that all want to delay the test. If you want to do that this time, I'm okay with it. There's no particular reason it has to be done on Wednesday. So let's have a vote from all 8 of the people that are actually here in class. Would you like to do the test on Wednesday or Friday? And it really just depends on what else you're going, what else you have going on that day. So if you have, let me see, somebody has a Syracuse final on Wednesday, delay as always. So what does that mean? That crying face, it means you don't want to delay or that you do want to delay? I'm not sure. I'm really not sure what that means. Be specific. Just write out, do you want to do it on Wednesday or Friday? Wednesday or Friday. Because, we don't even have the class trips and all that. Oh, that means Friday. We don't even have the class trips and all that. So we literally have extra time. So I kind of feel like not always doing stuff on Tuesdays, and if possible, just skipping on Tuesday. But don't quote me on that. Anyway, we got some people. Oh, this is going to be a close one. All right, so we got Friday. We got 2 for Friday, and we got 2 for Wednesday. Look at that. So coming in for Wednesday's going to win it. Look at this. 3-2. 3 people Wednesday, 2 people Friday, and we can, see what other people say too. So we only have 5 of the 8 people who are on here who are voting right now. But maybe if we get some more people on here to vote, it might turn the tables. You never know. But right now it's looking like Wednesday. And as I'm waiting, I want to look and see. So we had somebody said, how can we calculate the molarity of vinegar? All right. You guys know how to do that? Seriously. You literally know how to do that. I know that you guys know how to do that because you guys are my honors class. You remember the stuff we learned before. But you're not the first one. Leo, don't worry. You're not the first one to actually ask me. There's been other people that have asked me, how do we calculate the molarity of vinegar, right? So it depends on what your mass percent is. Let's suppose we have a mass percent of, let's say, I don't know. Let's say we have a mass percent of, you got 8% vinegar. You got extra strong vinegar. You probably don't have that, but it doesn't matter. All right, so let's suppose you have 8%. What does that mean? This 8%, I don't know exactly how they calculated their percents, but let's say more or less it's going to be a mass percent. Okay? Mass percent. All right? And if that's a mass percent, that means you have 8 grams of acetic acid in 100 grams of solution. Okay? And now we're going to make a few assumptions, and the assumptions are going to be pretty good. We don't have to have this exactly correct, right? Because we don't know the density of this solution. We don't know exactly what its density is. What we're going to assume is that this is 100 milliliters of solution. Now I know that's not exactly correct, okay? But we're going to assume that, all right? So this is approximately equal to 100 milliliters of solution. All right, well, let's make this a little bit simpler, right? Because molarity is in moles per liter. So if this is 8 grams per 100 milliliters, that means that's going to be 80 grams of acetic acid per 1 liter. Okay? So once you've got that, then you can calculate the molarity, right? Because all you need to do is look up, well, what in the world is acetic acid? You get the formula and you get the molar mass, and then you do your, I don't even, you guys know how to calculate a molar mass, right? And so you can get the molar mass of acetic acid, then you've got your 80 grams or your 50 grams or whatever the mass percent is, that grams, and then you're going to do 1 mole per, right down here is going to be the molar mass of your acetic acid, right? And you're going to get a number of moles. And that number of moles, because you calculated this per 1 liter of solution, that number is also going to be equal to your molarity, whatever that is. That is also your molarity. Right? And once you have the molarity, then you can use that number and you can use stoichiometry to calculate how much you actually need. Okay? Hopefully that makes sense to you guys. I didn't actually get a number because I didn't bother getting the molar mass of acetic acid. Save us a little bit of time. So, looking over here, getting some more votes. I like it. More votes. Who is Tariq? Tariq Dermis. And Amr Huki. Man, I don't even know how to say that. Yeah, just wondering, who are you guys? Are you guys actually in the class, or are you just voting for fun? That would be, that's totally cool to vote for fun. Don't worry, if you're not in the class, your vote doesn't count. So this is only for people that are actually in the class. But maybe, it could be people in the class that have just changed their names, interestingly. It's certainly possible. I don't know. Things like that, I wouldn't be surprised. But anyway, you guys in my class, if you're actually in my class and taking the test, you get to vote. You're welcome to be here. Anybody's welcome to be here. But Alex wants it on Wednesday, and she doesn't want you guys messing up with the vote. Anyway, let's see. Anyway, Leo, how can we calculate Mg2 plus HCl? I don't know what you're asking. Sorry, I'm going to come back to this. Leo, so on the lab, I know you had some problems calculating the molarity. Is this okay for you, Leo? Do you understand this now? And anybody else? I think that Jonathan, did you have a question on this too? I'm not sure. But anyway, so you have to calculate the molarity. Were there any other questions on the lab before we get started? Any other questions on the lab? Yes, that's good. Good. My question was on CN2. So when I replied on email, Jonathan, did you understand what I was talking about in terms of CO2? Did you get that? Or anybody else? Any other questions on the lab? So I'd like to answer lab questions before we get into the homework stuff. Okay. The lab, it's kind of simple in nature, but it's really complex when you get into all the different calculations. And I love it how it brings together all the stuff that we've learned. Yes, it did all right, good, that's good. So do we have to summarize the results in the conclusion? Yeah, that's pretty much what the conclusion is. We don't even have, I didn't even ask you guys to do like a results and analysis section, okay? Because of the nature of the lab itself, you only have a conclusion section, right? So you only have to do, what did I say? You have a, so you don't have a goal section. Instead, I wanted you guys to do an abstract just because that's more professional to do an abstract. And then you, of course, you have to do procedures, and then you have to do like your conclusions. I don't remember what else I said. Did I say, I don't remember whether I said you guys had to do a background or not. Whatever I said is that's what it is. But you don't even have to do any kind of tables, any kind of results section. That's what your video is. Your video is your results section. And then you have to do a conclusions, basically summarize, hey, this is what I did, okay? But the most important sections of your lab are your calculations and your video. Those are the most important parts, more important than any of the other parts. So that's what you should focus on for the lab, your calculations and your video showing me, hey, you actually did this, okay? The conclusions just, maybe like, 1 or 2 points just to summarize what you did. That's it. Okay, or if there are any problems, talk about that kind of stuff, how you overcame it, but you don't need to go and have any kind of lengthy discussion. There's no discussion section. Not important for this lab. Okay? All right, any other questions on the lab? Any other questions on the lab? I hope you guys enjoyed it. I wanted to have some kind of lab for you guys to do at home, and that's it, because there's most of the labs that we do, you can actually do at home, but this is one that you could. So I figured, hey, let's do this at home. So hopefully you guys enjoyed it, at least somewhat. And I don't want you to make the write-up to be too bad. I want to remind you guys the most important part of the write-up is the calculations. So don't worry, this is not English class. You're not writing an essay. I care about your calculations, and everything else is just there, to accompany it, to tell me, what your procedures were basically, and that's it. Okay? So no big deal on the abstract and on the conclusions. Really no big deal on those things. Okay. So if there are no other questions on that stuff, and right now it's looking like it's 3 people. So of the people that are in the class and at least claiming to be in the class and people that I know are in the class, let's just have right here a vote here for the test. We only have 5, so that's not really an actual full class vote here. But of course, a lot of people probably don't care. That's fine. Okay, so right now I counted, what was it? I don't know why I'm using all these different colors. I counted 3 votes for Wednesday and 2 votes for Friday. And if anybody else that's in my class wants to vote on when they want the test, just go ahead and say it in the comments section or in the live chat. Okay, so hopefully, today has been, Monday morning. I've just very, very recently put on the review up on Google Classroom. You guys should have gotten it. If there's any problem accessing that, just shoot me an email and I'll make sure you guys can get that. I'm not going to go over that today. I'll go over it on Tuesday. Okay, I don't know if this counts because they aren't here. Sam and Eliza said Wednesday in our class group chat. How do they? Okay, well, tell them to get online. I don't know if it counts either. Yeah, I'm just going to say they got to get online and vote. So I'm not voting people that I don't know who they are, right? Those people that are not in our class that voted. And I'm not counting people that don't actually come up to the live chat. So you got to actually tell them, hey, sign in to the live stream here, and then it'll count. If I don't have a scale, how can you do that? Good question. I said in the video. So Leo, back onto the lab. Good question about the lab. If you don't have a scale, you can still do it because you need to really only measure volumes. So for the acetic acid, almost every kitchen in America at least, and probably most kitchens around the world, should have some kind of volume measurements. So measuring cups, or measuring spoons or something like that. And so what you're going to get for acetic acid, you're going to get a volume, right? And then for your baking soda, I said, and I measured that 1 teaspoon is approximately equal to 5.1 grams of baking soda. Now, if you don't have a teaspoon, that's going to be an issue. You can look up online if you have, Leo. I don't know where you are. Are you still in America? Or did you go back to China? If you're in China, they probably have milliliter measurements, and those milliliter measurements you can probably get a conversion. You can just Google, right, 1 teaspoon equals how many milliliters. Convert teaspoons to milliliters. I don't know off the top of my head. You guys can look it up. Somebody here might know. So you're here. Okay. So if you're here, you should be able to get a teaspoon. Okay. So, and if you want, it depends on how big your bag is. Okay. So you calculate your mass of baking soda that you'll need, and then you just divide by 5.1 to get the number of teaspoons. Now, it's not going to be an exact measurement. Okay. This is not a completely exact lab. All right. And so I would, maybe even let's say you need, 7 grams of baking soda. Then what you just do is you give yourself 1.5 teaspoons, right? Now that's not exactly right, because 1.5 teaspoons is more like 7.5 grams-ish, more or less 7.6 grams. But that's good enough, right? You just make sure you have enough, all right? And so, like I said, if you need, let's say, for example, 7 grams, you just measure out 1.5 teaspoons. And so you should, in the kitchen there, have the 1 teaspoon, the half teaspoon, 1/4 of a teaspoon, and you should be able to somehow get, with those teaspoons, more or less the correct amount. Just make sure you have at least enough, maybe a little bit more, all right? Now, if you for example, if you only need 4 grams of baking soda, you don't want to measure out 2 teaspoons, because that's wrong, all right? You want to get the right amount, more or less, but if you have a little bit more, that's fine. All right, so let me see. Here we go. Wade is a cool name, but I don't know if you're in my class or not. And Sveti is also a cool name, but I don't know if you're in my class or not. I'm seeing Sam. Sam is in my class. All right, so Sam, that's a Wednesday, and so. Oh, Sveti, that's Eliza. All right, that's cool. The R for Redmond. All right, so that's 5 for Wednesday. It's looking like it's gonna be. That's fine. That's fine. See, that's why I didn't know the people. So guys, if you're Amr or Tariq, I don't know. Maybe that's somebody else in my class. But if that's you guys, I can count your votes. But I don't know who you are. Okay. So, all right. A lot of time spent on talking about the test in the lab. Any other questions before we get into the homework? Looks like no questions. All right. So, let's go ahead and jump into it then. Let's see. We are going to talk about these problems here for the test. Sounds like people, because they went on Wednesday, sounds like people know what they're doing, and that's great. And if you have a specific conflict at the same time, we can talk about that, but you shouldn't have any conflict at the same time, I don't think. All right, so we have a gas added to a rigid container with a constant volume. If the number of moles of gas triples and the absolute temperature doubles, what happens to the pressure? So this is one of those things where it's like a combined gas law. And in this case, in this combined gas law, we are talking about a constant volume. So if you remember, so I'm just going to redo this, but we have PV equals nRT. We have R is the constant, so I'm going to put all my variables on one side. So that gives me PV over NT is a constant, is R, right? And in this case, the volume is also a constant. So I'm just going to remove that from the equation, and I'm going to say, okay, that means that P over NT is a constant. And once I know that that's a constant, then I can go ahead and make up my equation that I need. And that's going to be P1 over N1 T1 equals P2 over N2 T2. And let's see, so what I'm doing is, in this case, I don't even have actual numbers. So I didn't even read this problem completely. So we say gas is added to a rigid container. We have constant volume. If the number of moles of gas triples, okay, so N is tripling, and the absolute temperature doubles, what happens to the pressure? I'm not even going to calculate using this equation. I'm going to look at this here instead. So what happens to the pressure? All right, so what I'm going to say is if the number of moles of gas triples, my pressure is going to be tripling too. Now, if the absolute temperature doubles, well, what happens when the temperature doubles? That means my pressure is also going to double. So that's going to be, it's going to be 3 times, and it's going to be 2 times. So the pressure is going to, I don't even know what that's called. It's going to be 6 times as much, okay? And that's going to be the answer. So how can we do this? You can plug in numbers here if you wanted to. And you could just say, another way to do this would be to say, okay, my P1 is going to be 1, okay? And what I'm going to do, I'm just going to make these all 1. So P1 is 1, N1 is 1, T1 is 1, okay? And my P2 is going to be what I'm solving for. My N2, because that's tripling, this is going to be 3. And my temperature, my absolute temperature is going to double. So this is going to be 2. So 3 times 2 is 6, okay? But we need to multiply both sides by N2 T2 to calculate P1, right? This is going to be 1, 1, 1, so this is all 1. And so N2 T2, that's going to be 6. And so P2 is going to be 6, okay? So the pressure is going to be times 6 the original pressure, okay? And so you can use the equation to do it, or you can think through the equation just thinking about, and I want you guys to be able to do that, think about what each one of these things does, right? The number of moles, adding more gas is going to cause the gas to increase in pressure, right? Increasing the temperature is going to cause the pressure to increase. So each of those things is going to multiply together to make it 6 times the amount of pressure, okay? So expect a question maybe like that on the test, whether it's a combined gas law or any of the other gas laws that we talked about, okay? All right, next up. Let's do it this way. Number 5, we got 0.391 moles of air inside a balloon, and it has a volume and temperature, and we have gas escaping, volume decreasing, the pressure, assume the pressure remains constant. So this is, now we've got some numbers, we actually have to do the calculation. And notice that I'm using very annoying units like gallons and anything else here. Because of that, because those are gallons, we're not going to want to convert this to liters in order to use the ideal gas law. So we're really going to want to save time by using this combined gas law. So we have, once again, we have PV over NT is R, right? And because of that, we have, what did we say was constant? Pressure is remaining constant. So we can remove P from the equation, and that's going to get us, it's going to get us V1 over N1 T1 equals V2 over N2 T2. Okay, that's the equation that we're going to be using to solve this. And we want to know what is the new temperature of the air. So we're solving for T2, so which is a little bit annoying because it's on the bottom. But I think the easiest thing to do is just going to be to cross multiply, all right? Or you could flip them both, but I've already got it this way. So I'm going to cross multiply, and that's going to get me V1 N2 T2, this cross, and then that's going to get me equals V2 N1 T1. And then solving for T2, the new temperature, that's going to get me T2 equals V2 N1 T1 over V1 N2. Okay, very important that you're careful with your ones and twos. It's so easy to make a mistake here and flip them, but make sure you're making sense of all these. So we have, this is going to be our N1 inside of a balloon. It has a volume of this. This is going to be our V1, and temperature of this, but that, of course, is in Celsius. So your actual T1 is going to be 290, I think, 7.4. That should be right. And then we have a 0.1. Now, this is also another tricky part. This is 0.123 is not N2, okay? And that's a very easy pitfall to fall into, okay? 0.123 moles of gas are allowed to escape. So that's the amount of gas that is being removed. So your N2 is what? N2 is going to be N1 minus 0.123, right? So that's going to be your N2. Let's go ahead and calculate that now. 0.391 minus 0.123. That's going to be 0.268 moles. That's your N2 value. And then the volume is going to be decreasing, so this is your V2. So now you can plug everything in. So it is a bit of a pain with all of these, but you really, really need to keep track of what's your N1 and your N2, and using these subtractions if necessary, paying attention to the wording, very, very important in all this. So my V2 is going to be 1.64 gallons. My N1 is 0.391 moles. My T1 we said was 297.4 Kelvin. The temperature must always be in Kelvin. Other units can be in other, you can have volume in gallons, no problem, but temperature must always be in Kelvin no matter what. My V1, 2.45 gallons. My N2 is going to be your 0.268. All right, and that's moles. Now we can solve, plug everything in, and 1.64 times 0.391 times 297.4 divided by 2.45. And you can put the bottom in parentheses, or you can do it this way and just divide by another thing. What I'm going to do is I'm going to use the previous answer that I had, the 0.268, and that's going to give me my final answer. Not a big change, right? That's, well, why is that? Because the temperature is, so that the number of moles of gas is decreasing, but the volume is also decreasing, and so both of those are going to mean that the temperature is not going to have a big change, right? Because as the volume as the number of moles decreases, the volume decreases. So we don't expect a big change in the temperature, and it's not a big change. So we're getting 290.4, 290.4 Kelvin. And if you want to convert to Celsius, you can just subtract 273, and that's going to get you 17.4 degrees Celsius. Okay, any questions on that? All right, that's a point there, 17.4. So if you guys have any questions, just feel free to stop me. All right, this is now keep in mind on the test itself, I might ask you a question where I ask for a temperature, where I ask for a volume, where I ask for moles. I could ask for anything, and you need to be prepared to solve for anything. And I could have volume constant, pressure constant, moles constant. I could have temperature even constant. And you need to be able to figure out what exactly the equation is. Now we're going to do that simply using this ideal gas law here, and you should be able to go from there. Okay? Do you need to calculate? No, you can leave it in Kelvin. Unless I specifically say what is the new temperature in Celsius, you can leave it in Kelvin. I just did that because I wanted to. You don't have to actually convert it. Okay. So next, airbags. We've had airbag problems before. I think we have. Maybe we haven't. Well, you guys did an airbag lab. That's what we did. So car airbags. So the actual airbags, when you guys did the lab, you probably noticed that the airbag that you guys did with baking soda and vinegar took a few seconds to inflate, maybe 10 seconds or 15 seconds to fully inflate. So car airbags can't use baking soda and vinegar. It would just take too long, right? You would already hit the dashboard with your head before the car bag actually inflated. The reason we use this reaction in car bags is because it's so fast. This is a super fast reaction, right? This is called sodium azide, which, as you notice, is not your normal. This is not sodium nitride. This is sodium azide, which is a different kind of thing. This is actually N3 minus, is a polyatomic ion. Now, we're going to go ahead and balance this reaction always before we do any kind of calculations with it. So we have 3 and 2, so we're going to make this 2 and 3, and then we just balance the sodium at the end, put a little 2 there, and we're good. Okay? So typical airbag has a volume of 49 liters. Let's go ahead and calculate the mass of sodium azide needed to fully inflate the airbag. And guys, by the way, in case you guys are wondering, the test is still going to be on Wednesday because we have 5 to 2, 5 people voting for Wednesday, 2 people voting for Friday. So sorry about that, anybody that wanted it delayed till Friday. All right, typical airbag is a volume of 49 liters. Calculate the mass. So this is right here, that's our volume, right? And it tells us what we're assuming. This is going to be our pressure, this is going to be our temperature. Now those pressure and temperatures are not going to be exact, right? And it's going to depend. Obviously the car can go to different places. It can be summertime, it can be wintertime, and that's going to affect this, right? If it's summertime, that airbag is going to be more inflated than it will be in the wintertime, right? Because the temperature is going to affect things. If you're on top of a mountain, or let's say down low, you know, on at sea level, that's going to affect things. But we're going to say more or less, these are some reasonable assumptions. So let's go ahead and do this. You have PV equals nRT. What are we calculating here? What do we solve for? We solve for N, right? We need to solve for N because we need to calculate the mass, and we can't get the mass until we get the moles. So that's going to get us N equals PV over RT. Just divide both sides by RT. And plug in some numbers for pressure. That's 1 atm for pressure. We had 49 liters for volume, 0.08206 for R, and my temperature is 25, which is 298 Kelvin. Okay? And then we're going to plug that in, and we will get our answer for moles. That's going to be 49 divided by 0.08206. And you can store R in your calculator. I maybe even, you know what, I probably have it stored, but anyway, I forgot. 298. And that's it. 2 moles. Look at that. I did not expect this number to be that nice, because these are real numbers. 2.00 moles. These are real numbers of, let's say, a real typical airbag is that size. So, hey, it's more or less exactly 2 moles, which is pretty cool, which means this is going to be a fairly easy calculation. It's going to be twice the molar mass of sodium azide, and we can get the molar mass of sodium azide from the periodic table, which is, excuse me, 1 sodium and 3 nitrogens. So 22.99 plus 3 times, right there, 14.007. So that is our mass of sodium azide, or molar mass of sodium azide. But we actually need 2 moles of it, right? So we're just going to multiply that by 2 times 2, and that's going to be 130 grams. Okay? Or actually, it shouldn't be times 2. It should be times 2. I'm making a rounding error here myself now. Let's get this again. 2.00377, which is times 2.00377. All right. Yeah, still 130. Okay, 130 grams with, there's only really 2 sig figs anyway, so it didn't make a difference. So 130 grams of NaN3. Okay, questions on that one? All right, let's go on to the last one, Jacques Charles. And again, these are realistic numbers. I try my best to get realistic numbers for these things. Now, we don't historically know the exact volume of this, okay? But we have some estimations, some pretty good estimations. So, number 8 is a realistic problem of Jacques Charles' first hydrogen balloon. If you guys weren't here when I told the class before, that Jacques Charles was the very first person to make a lighter than air balloon, and the very first person to ride in a lighter than air balloon, and the second person ever to ride in any kind of balloon. He would have been the first if his first balloon hadn't been destroyed by angry farmers with pitchforks who thought that it was a UFO. Anyway, so it was filled with 380,000 liters of hydrogen gas, which is a lot. If Charles used the following reaction to generate hydrogen, which he did actually use this reaction, what volume of 4.5 molar hydrochloric acid did he need? Now, this number's made up. I have no idea the concentration of hydrochloric acid that he actually used, but, you know, it's reasonable. And maybe, yeah, who knows exactly what the molarity of the hydrochloric acid he used was. Okay, so let's go ahead and do this one. We have to balance the equation first, which isn't too bad. We've got 2 hydrogens, so we need 2 HCl's. We have 2 HCl's, which means we also balance the chlorine, which is also balancing the iron. So that's it for balancing. So balancing is done. Now, ideal gas law, we have a volume, and we need to calculate a moles. All right, so we have, once again, PV equals nRT, but we need to solve for N, which we just did earlier. So this is going to be N equals PV over RT. Now, keep in mind, we should be able to do this kind of calculation in reverse. Let's suppose I tell you in one of these problems, let's say I tell you the mass, you should be able to use the mass to then calculate the moles, to then calculate the volume. So I could ask you in the problem, how many liters of nitrogen do you produce? Or I could ask you how many, the volume of hydrogen produced. So be prepared to do it like this, or also to do it in reverse. So I'm sorry, I probably should have done one of these problems in reverse, but make sure you're able to go from, let's say, your volume to a mass, or from a mass to a volume. Okay? All right. And I think your review guide has a problem that does it in reverse, and it has actually calculating pressure rather than volume in that case. So yeah, so you got the review problems to do that too. So anyway, let's go ahead and plug some numbers in. N equals PV over RT. So my pressure, we're going to assume once again this 1 atm. My volume of a ridiculously large number, but that's normal for balloons that can actually lift people, like hot air balloons or blimps and stuff. So that's normal to be that large. 0.08206. And our temperature of, was that 298 Kelvin. All right, so let's calculate that. And let me see, like I said, you should probably go ahead and calculate or put R in your calculator. Let me see, which I have it in my calculator. So let's do this. 380,000 divided by R. Oops. Divided by R and divided by 298. That's going to get me over 15,000 moles. So 15,000, basically 539 moles of hydrogen gas. Now we're not there yet. We have, let's go ahead and do this conversion. We got 15,539 moles. Obviously we should only have 2 significant figures, but let's go ahead and convert this. So we have moles of what? This is moles of H2, because that's the gas that's filling that up. And we want to convert it into, first, convert it to moles of HCl. So this is important, right? Sometimes in your balance reaction, you'll have numbers here. And in this case, we have 1 H2 is going to go on the bottom because that's what we're starting off with. We need 2 moles of HCl for every 1 mole of H2 from the balance reaction. And last of all, we're going to convert these moles into a volume, because it says what volume do you need. And so in that case, because we have 4.5 moles per liter, we're going to put our 4.5 moles per liter. That's our concentration or molarity of your hydrochloric acid. So let's just use this. We're going to multiply this times 2, right? Times 2 because that's on top, and then divide by numbers on the bottom. Divide by 4.5. And that gets me, we're going to round this to 2 significant figures because we have only 2 significant figures right there from the pressure and also from the molarity and also from basically everything has 2 significant figures. So this is going to be 6,900. 6,900 liters. And if you guys want that in gallons, I believe a gallon is 3.8 liters, so divide by 3.8. And that's going to be 1,800 gallons. Now, you don't have to do that, right? But if you want it in gallons, just, hey, that's 1,800 gallons. So that's a lot, right? It would even be a lot to, let's say, go to Walmart and get 1,800 gallon jugs of distilled water or something like that. This is hydrochloric acid. So that's a lot. But he wanted to fill up a balloon, and to carry himself. So that's why it was so much. All right, so we're done. I don't know, is anybody still with me? We got 9 people with me. Awesome. I'm going to go ahead and sign out in a couple minutes, but do we have any other questions? I don't see any more questions in the chat. Hopefully you guys getting these right. Any questions at all? Okay. Test is going to be on Wednesday. Test is going to be on Wednesday. Unless anybody last minute votes for Friday. Anybody else care? Jake Covers, do you care? Anybody else? Okay. So test is going to be on Wednesday then, just like planned. And then on Friday, we'll go ahead and just start the new stuff. We're going to take a little bit of time after this test. You don't mind? Okay. We're going to take a little bit of time after this test to talk about just a very short section on global climate change and the greenhouse effect. So kind of an extension of environmental chemistry and gases. And then we'll talk about, have a short unit on electrochemistry and then finish out the year with nuclear chemistry. You have a question about the lab? Okay. Shoot. Go ahead. Ask a question about the lab. I'm waiting for your question about the lab. And I do have another class here, so I got to sign out. I got about 3 minutes before I have to sign out here. But I can answer one question about the lab. Okay, so do we have to calculate the yield for all the products or just CO2? Really, well, what do you care about? You care about filling up the balloon, right? And so if you care about filling up the balloon, you only care about the volume of the gas. Everything else is going to have negligible volume, and so you don't care about anything else. You only care about carbon dioxide. So I said, and you don't even need to calculate the yield. Basically, what I said was assume that you are going to get less than 100% yield. So assume, let's say, you get 80% yield or something like that. So if you get 80% yield, that means, let's suppose you needed to get, you need to add, let's say, 6 grams of baking soda, right? Now, because you're only going to get 80% yield, well, then you're going to just divide by 0.8, and that's going to increase everything, okay? And so, yeah, that's literally all you're going to do. You don't need to calculate the percent yield of anything because you don't have a way to measure anything, so you're not going to actually calculate the percent yield of anything. I just said assume it's not 100% because it's never going to be 100%, and assume it's like 75, 80%, which seems reasonable for this reaction, and that's going to increase the amount of stuff you use, right? So that's it. Okay, any other questions? Okay, if not, I'm going to go ahead and sign out. Oh, one more question. All right, Sveti. Is it bad if my calculations ask for 2? Yes, your calculations are definitely off if you need 2 liters of baking soda. That's crazy. Unless you're trying to like, let's say, fill up some enormous bag? I even think 2 liters of baking soda might even be too much, even for a trash bag. But yeah, that's gonna be too much. So try to redo that. Okay. Your bag is that's a nice size bag. That's a gallon bag. Okay, so that's gonna be a gallon bag, which has clearly a little bit more. But yeah, 2 liters of baking soda is definitely off. I'm gonna let you know. Let me see, off the top of my head, what would that be? What would ballpark figure be? You're going to be in maybe a couple tablespoons. I don't know exactly, but I'm just estimating. I would think maybe a couple tablespoons for that size bag, and that's it. Not liters of baking soda. So redo your calculations, okay? All right, I got to sign out now. See you guys. Have a wonderful rest of your day. Why did you put like 5? Oh, I was trying to trick you guys. That's why. Nice question. I actually didn't put 5 teaspoons. I was using I was using half teaspoons and quarter teaspoons just to trick you guys, because I wanted people to think I was putting a whole bunch in there when I actually wasn't. I only really put 1.5. Oh, I shouldn't say that. Anyway, I was trying to trick you guys when I put like 5 spoons in there, because I thought it would look cool, because you didn't know which part of the thing I was using. I was using the half teaspoon and the quarter teaspoon when I did that. Anyway, so your calculations keep on getting less than 1. Well, maybe you have a smaller bag. My bag, I used a quart bag, but it actually had more than a quart. It ended up having being more than a liter, right? Even though it said it was a quart bag, it was more than a liter of gas. And so if you have a sandwich bag, it's going to be even smaller than that. Okay? But if you're getting a little bit less than 1, make sure you use at least 1. Okay? So anyway, I only use for mine, I think I only use 1.5 teaspoons. Okay? But I looked like I used more because I was trying to trick everybody. And it looks like I did. Everyone was so confused. Yeah, that was, you couldn't tell which spoon I was using. It was pretty cool. I did it on purpose. So you guys wouldn't just try to copy me and be like, oh man, Mr. Ketz used 5 teaspoons, and so I got to use 5 teaspoons. I know. Wasn't that awesome? I did trick you guys. I tricked you guys. Nice. Anyway, I got to sign out. I get class in a minute. See ya. Bye.